Welcome back. So you can write the most amazing, elegant JavaScript function in the world. But if it can't actually interact with a web page, it's really just code sitting in a file. So how do we build that bridge? That's exactly what we're digging into today. Right, so in our last explainer, we covered functions, those awesome reusable blocks of code that get specific jobs done. But most of the time, those jobs need to affect what the user actually sees and does in their browser. And that really is the big question, isn't it? How does a function sitting inside a JavaScript file reach out and actually change what you see on a live website? How does the code even connect the page? Well, the answer is all about the bridge that connects your script to the browser. And that bridge is built on something we can think of as the page's digital blueprint. That bridge is called the Document Object Model, or the DOM. Now, the most important thing to get your head around here is that the DOM isn't a language, it's a programming interface. It's a live, in-memory representation of the entire web page that our code can directly talk to. The DOM organizes the page into this really logical tree structure. Every single piece of your HTML, from the main HTML tag all the way down to a single paragraph, becomes what's called a node. This whole thing creates a structured map of the document that our code can then navigate and change. So if the DOM is the blueprint for the house, then JavaScript has all the tools, the APIs, to read that blueprint and make changes on the fly. We can add new walls, paint existing ones, or change the text on a sign, all with code in real time. Okay, so how do we actually use these tools to edit that blueprint? Well, it pretty much boils down to 4 core types of interactions. Yep, these interactions fall into 4 main buckets: finding elements, changing them, creating or getting rid of them, and, of course, responding to what the user does. Let's do a quick pass on each one. First, you gotta find the element you want to mess with. We can use methods like document.getElementById to grab a specific node right out of the DOM tree. And once we have it, we can modify its properties, like changing its text content to "Hello, developer." But what if the element doesn't even exist yet? No problem. We can also create elements completely from scratch using document.element. Then we can use a method like appendChild to just inject that new element right into the DOM, making it appear on the page instantly. And this is where it gets really fun and interactive. We can attach event listeners to elements. This basically tells our code, hey, just wait. And when a user does something, like click this button, then and only then run this function. This is what creates the entire behavior layer of the web. Okay, so we've got the blueprint, the DOM, and we've got the tools to change it. But just like in real-world construction, you need a building code, right? A set of rules to make sure everything you build is safe and predictable. In JavaScript, that's called strict mode. And turning it on is incredibly simple. You just place this exact string, use strict, at the very top of your script file or at the top of a specific function. That one line opts your code into a more modern, much safer version of the language. So what's it actually do? Well, at its core, strict mode takes common coding mistakes that would normally just fail silently in what people sometimes call sloppy mode, and it turns them into loud, explicit errors that actually stop your code from running. And why is crashing your code a good thing? Because a silent bug is the absolute hardest kind of bug to track down. A loud error, on the other hand, tells you exactly where the problem is, making your code way more robust, secure, and a whole lot easier to debug. The benefits here are huge. For instance, it stops you from accidentally creating global variables, which is a massive source of bugs in big applications. It also helps JavaScript engines optimize your code so it runs faster, and it even future-proofs your syntax. It's really all about writing cleaner, more professional code. This table really shows the difference. Look at that first line. If you assign a value to a variable you never declared, sloppy mode just silently creates a global variable for you, which can cause total chaos. Strict mode, it throws a reference error right away. Same for the this keyword. In sloppy mode, it can point to the global object, a big security risk, but in strict mode, it's safely undefined. Here is a perfect example. Let's say you try to assign a value to a variable, but whoops, you mistype the name. Without strict mode, your code would just create a new global variable called mistyped variable and keep on going, leading to a nasty bug you might spend hours trying to find. With strict mode, you get an immediate reference error. Problem solved right then and there. So let's connect these two big ideas. The DOM and strict mode aren't just two separate features. They actually work together to form the foundation of modern professional web applications. You can see it's a really clear, logical flow. First, you have the DOM, which acts as the blueprint for the page's structure. Second, you have the DOM APIs, which give JavaScript the tools it needs to edit that blueprint. And third, you have strict mode, which acts as the building code, making sure your script logic is safe, predictable, and free from those sneaky silent errors. And here's the best part for anyone doing modern development. If you're using features like ES modules or classes, you don't even have to think about this. Strict mode is automatically enabled in those contexts, so you're getting all these safety benefits by default. So, we've seen how JavaScript looks outward to interact with the structure of the page, but that brings up a really interesting question. How does JavaScript look inward? How does it manage its own context while it's running? And that is exactly what we are going to tackle next time. We're going to dive headfirst into one of JavaScript's most misunderstood, yet most powerful concepts, the this keyword. You are not going to want to miss it. See you then.